Hello and welcome to our project SIRA 2.0. We are Reactor, operating at Pontificia Universidad Católica del Perú. We are a team of multidisciplinary students and professionals ranging from different engineering, design, science, and management disciplines. We are a team of 15 young entrepreneurs devoted to the development of robotic space exploration and the restoration of the environment. SIRA 2.0 is our second Mars rover, a 6-wheeled Mars exploration rover with a 6 degrees of freedom robotic manipulator placed at the rear end of the equipment deck, inboard instrumentation to analyze and store different types of samples. Mainly constructed with 6061 TIG welded aluminum profiles, it weighs less than 60 kilograms. SIRA means the seeking scorpion in Quechua, native language of the Incas. The scorpion is one of the most implacable animals that live and thrive in the desert. Remote control operation works with a 5.8 GHz antenna based in the Basebox 5 communications module. Rover mobility relies on its 6 individually driven wheels with brushed geared DC motors with a maximum torque of 8.6 Nm each. Rover's design lets us turn around the rover in its own axis, like a tank. The suspension system consists of a modified rocker bogie and was designed assuming that only 4 wheels are touching the ground simultaneously. Maximum traverse speed is 0.5 meters per second. The robotic arm has 6 degrees of freedom which can be actuated individually. Fabricated with aluminum square profiles, it can reach items up to 1.5 meters above the ground and lift up to 4 kilograms. The end effector is based on an endless screw system and allows us to manipulate different kinds of devices, such as tools, valves, switches, and even lets us measure the voltage in a standard E-type plug. The end effector was especially designed to manipulate cylindrical items. In SIRA 2.0, there is a physical stop button in the rover which mechanically and electrically disconnects the batteries to any actuator in the rover, avoiding accidents. In order to drill the Martian soil, we first have to find the most suitable place for it. This is done via a stereo system of 2 panoramic cameras that allows the driver to look for the best place of interest and determine a 3D coordinate of the space surrounding the rover. The cameras are mounted on a 3D printing housing. There are several sensors that comprise the inboard laboratory: the air and soil temperature sensor, soil humidity sensor, pH sensor, UV sensor, and a nanospectrometer. Particularly interesting is the UV sensor, since UV radiation ionizes atmospheric gases and damages life as we know it. For this reason, knowing the UV radiation flux at the surface of Mars is important to understand the current habitability condition and identify target sites of sampling. Also, UV radiation origins photochemical reactions in the atmosphere and on the surface. The nanospectrometer NSP32 lets SIRA 2.0 to obtain accurate results of proteins, carbohydrates, also air and water quality. To drill, we have a system that comprises a drill bit inside a tubular structure. We see here the conceptualization and building of the system. The drilling system has one small scooping arm incorporated in order to spoon out superficial dirt samples. We want to participate and win ERC 2018 because we believe we can inspire other Peruvians to break traditional patterns and expand their capabilities to transcend the limits that exist today in Peruvian industry. We want to show that, through talent and effort, we can compete with other nations in space industry and exploration, though we don't have a strong space agency. We know that research and exploration of space is a key aspect of human nature and humanity's future.